Topics discussed in Ernest Ruthford's short documentary film include
brief biological info,
major contributions to atomic theory,
gold foil experiment,
and radioactive decay.
Today in school, we are here to learn about Ernest Ruthford and his contribution to chemistry. Here's some information we already know about him. Ernest Ruthford was born August 30th, 1871 in Nelson, New Zealand, as the fourth child with 6 brothers and 5 sisters. His parents were Martha Thompson and Jane Ruthford, who were both immigrants who struggled to support a large family.
Ernest was first educated at a government school, and then at 16 years old he went to Nelson College School. In 1889, he got awarded for university scholarship and went to University of New England in Wellington, where he set foot in a Canterbury College. In 1893, he graduated MA in physics science and a double first mathematics. Continuing his research at college, he received the Bachelor of Science degree, which got him a science scholarship to Trinity College, Cambridge.
In 1894, he was awarded the Bachelor of Arts in Science degree for studentship of Trinity. In 1900, he married Mary Newton and later had a daughter named Aline. In 1907, he went to England to become a professor of physics at the University of Manchester. In 1919, he accepted the invitation of Sir Joseph Thomson as a candidate professor at Cambridge.
The atomic theory, which led to amazing scientific breakthroughs in modern chemistry, would have completely failed without Ernest Ruthford.
The crucial contribution was the discovery of the nucleus and the protons.
Nucleus and protons are majority of an atom's weight, while protons define the type of an element an atom is.
Gold foil experiment, conducted in 1911 at the University of Manchester, was the key to his discovery.
It all started when Ruthford fired a thin beam of alpha particles at an even thinner sheet of pure gold.
Because these particles are given off various radioactive decay processes, simple of radioactive metal inside a lead box with a small pinhole in it.
Majority of the radiation given off to form the alpha particle absorbed by the lead, a beam of alpha particles escaped the pinhole, head on for the gold foil. The gold foil was surrounded by a decor screen, which would signify when being an alpha particle.
Ruthford discovered that 1 in 20,000 alpha particles passed right through the gold foil.
The experiment proved that the atom is mostly empty space with tiny, dense, positively charged nucleuses.
From here, this led to the nuclear model of an atom. This model includes a small positive nucleus surrounded by negative charged electrons.
This photograph, shown up here, is Ernest Ruthford on the right, with Hans Ziegler at the University of Manchester. Ernest Ruthford made this analogy about the gold foil experiment results.
It was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as you fired a 15-inch shell at a piece of tissue paper and it came back and hit you.
Radioactive decay is a process in which unstable atomic nucleus loses energy by radiation.
The 3 most common types of decay are alpha, beta, and gamma decay.
The radioactivity was the work of Henry Becquerel and Mikhail Skonsky, but further, each was done by Ernest He was Ruthford. The first to understand and point out that all elements of a decay are a coordinate with the same mathematical exponent formula.
Also, scientists and his students discovered that many decay processes resulted in the transmutation of one element to another. These were then formulated to describe alpha and beta decay.
Alpha particles are released when a nucleus is too heavy. This means that there are so many protons and neutrons in the nucleus that the nucleus becomes unstable. The alpha particles consist of 2 protons and 2 neutrons. Beta particles are fast-moving electrons produced when an atom has too many neutrons. In order to keep the atom stable, one of the neutrons convert into a proton.
Ruthford was able to understand alpha particles by his famous gold foil experiment we explained. Alpha particles were observed to scatter backwards from the gold foil. His explanations of the observation were the scattering was caused by a hard, dense core at the center of an atom, the nucleus.
Thank you for watching!